Number one is to ensure that both limbs end equal. And at the end of the day, the knee joint is parallel to the ground, ankle joint is parallel to the ground, and the linear deformity should be in slight valgus than in varus. So if you are able to achieve this, you have done it right. So whether you spend 1.5 lakh rupees and buy a complex software and mess it up, or you just buy a simple 500 rupee ring and do a brilliant job, it's all dependent on your carpentry, on your gardening and not carpentry. And here remember that the limb is more of soft tissue than bone. We only see the bones on X-rays. We make the drawings on bones. We make the geometry designs on the bones. We use the software for the bones. They are not seeing how the foot goes into iguanas. They don't see how the knee goes stiff. As he said, as people are repeatedly saying, Ilizarov is not one fit and forget approach. You have to continuously keep going. Dr. Jhunjhunwala needs no introduction. A living legend of orthopedics, the most magnificent orator, former president of Indian Orthopedic Association, former president of Assam, India, author, teacher, and even at this age, one phone call and he's left all his work and flown us to enlighten us with his wisdom. I am blessed to have you here, Dr. Jhunjhunwala. Please.
Good afternoon. After good lunch, possibly you have little nap already. Now don't sleep. I'm going to talk about principles of deformity correction, what is CORA, and malalignment test. The malalignment test has been devised to correct the deformity by Professor Dor Paley, and I think what work he has done is a tremendous and worth mentioning. CORA is called center of rotation axis. That is C-O-R-A. That is CORA. The center of rotational axis is very, very important. The intersection point of the proximal, and this is the axis of the proximal fragment. There is a deformity here. This is the axis of the distal fragment, and where they join is called the center of rotational axis, and that is called CORA. This is CORA. See, the mechanical axis planning, reference point is joint center to joint center. Anatomical axis planning is reference point follows the mid-diaphyseal course and representing the diaphysis of the bone. Here you can see the axis of the proximal fragment and distal fragment, they join here, and that forms the reference point following the mid-diaphyseal course and representing diaphysis of the bone. In lower limb, femur has mechanical as well as anatomical axis. The mechanical axis is the center of head of femur. To the center of the knee is the mechanical axis, and the piriformis fossa to the center of the knee is an anatomical axis. So the femur has two axes, the tibia has one. So what CORA we can analyze, the level of deformity, it is a single level or multiple level, degree and magnitude of deformity, type of deformity, angulation or translation, plane of deformity, whether it is a sagittal plane or coronal plane, and to determine the true apex of the deformity, to choose the level of the osteotomy, and to determine the position and type of. So understand the deformities of the lower limb, it is important to first establish parameters and limits of the normal alignment. The exact anatomy of the femur, tibia, hip, knee and ankle is of great importance. There are two components, whether joint alignment or joint orientation. Joint alignment refers to the collinearity of the hip, knee and ankle. Orientation refers to the position of each articular surface to the axis of the individual limb segment. Normal alignment and joint orientation in frontal plane, you should have a full X-ray of the limb from the hip to the ankle so that you can align and you know where is the deformity. So normal axis is the center of the head, center of the knee, tip of the trochanter to the center of the knee, that is at 90 degrees angle. Usually a condylar line joining two condyles of the femur and mechanical axis of the femur. The outer angle is 87 plus minus 3, and a line joining the two condyles of the tibia and a axis of the tibia, mechanical axis or the anatomical axis of the same tibia, and the inner angle is 87 plus minus 3. And if you join a transverse line of the not to medial or lateral malleolus, but a transverse line, that gives a 90 degrees angulation here. So any deviation from these angles or this angle or this angle is the deformity. So full length X-ray is very, very important. You draw the mechanical axis, this line, measure this angle, and find out whether there is change in the angle. So identify the origin of malalignment, whether it is in the femur, whether it is in the knee joint itself, or it is in the tibia. Now, how to correct any deformity? Basic principles is that you have a upper fragment which is like this and lower fragment which is like this. So you fix up the upper fragment right angle to the axis of this proximal fragment with this ring and this ring. So these two rings make one block of Ilizarov ring, and these two rings make another block of Ilizarov rings. Now between these two blocks of Ilizarov rings, where to put the hinge and where to put the distraction rod, that we will just check. Now this, you have put a two-ring block in the proximal fragment, two-ring block in the distal fragment, and this is the ring, this is the hinge where you have put on the convex border at that level, on the convex border at the level of the CORA. So when you open this distraction rod, you get a nice triangular wedge correction and regenerate formation, and that's why it is called a open wedge hinge. The same hinge you are going to put, but if you put it away from the bone, then you get correction as well as little lengthening of the bone. So this is called a distraction hinge. The third type is translation hinge. Now this bone is going like that, this bone is going like that. So the axis of this comes up to here, axis of this goes here, and where those two join, it will join here. So this is the CORA for this particular case, and therefore if you put this hinge at the level of the deformity, you will not get a correct deformity correction. But if you put this hinge at the CORA level, then you will get a nice translation of this fragment and give you absolutely good deformity correction. Now, to correct the deformity, olive wires are very, very important. Now, if you want to correct a bent stick, how you hold it with this thumb here, index finger here, thumb here, and index finger here. And when you press this thumb on this, then only this bent stick will get corrected. And this is the idea where you have to put your olive oil. Your olive oil must come here, here, on this side here, and must come here. Then only your slipping of the frame will not occur. Otherwise, the whole frame will slip on one side as you do the distraction process. So olive oils are very, very important. So you can see here, when you put a olive oil on this side, at the periphery you have to put it on the concave side, this, and on the convex side you put it in the center. And then you put a hinge here, distraction rod here, and you get a good correction. These are basic principles I am talking. You first, how you correct the deformity, if there are multiple deformities. You do the angulation correction first, then lengthening you can do it, rotation you can do it, and then you can do translation. How fast you can correct the deformity? That is 1 millimeter per day, and according to the Ilizarov technique and according to the Perez's work, 1 millimeter per day should be divided into 4 phases, and that means 0.25 millimeter every 6 hourly you do lengthening or deformity correction, whatever it is, to form the regenerate. The regenerate is formed during the deformity correction or lengthening, that is 0.25 millimeter per day. If you do it, then you get a maximum regenerate formation. But if you do it 2 millimeters per day, the regenerate will be very poor. And to get a maximum regenerate, you have to do 1 millimeter per day, and that is 0.25 millimeter every 6 hourly. Now, how much distraction per day you do? You have put your olive wire here on the concave side, olive wire on the concave side here, and then olive wire here on the convex side, and you have put it, this is the distraction rod. You put 2 hinges here and 1 distraction rod, that gives a proper correction. I will show you. Now, this distraction rod, this is to be rotated 0.25 every 6 hourly. But if how you calculate this, how much you should rotate here, it is not only 0.25, but it is different. So you measure from the hinge to the distraction rod. You measure this point on the X-ray. You take another next day X-ray. Put 2 hinges coming on each other. The shadow of the 2 hinges coming on each other, and a distraction rod. So if you say that the 2 hinges X-ray shows this line, then measure from hinge to the distraction rod on the X-ray. Say this is 12, and measure from hinge to the concave border of the bone. That is 3. So 12 divided by 3 comes to 4. That means you have to rotate 4 millimeters of this distraction rod to get 1 millimeter opening here. And therefore you have to do 1 millimeter of distraction rod every 6 hourly to get 0.25 millimeter opening every 6 hourly here, so that in one day you will get only 1 millimeter opening here. Because you are doing 4 millimeter here, according to the calculation, you have to correct 1 millimeter opening. Your idea, your aim is to get 1 millimeter opening here, and therefore you have to do, according to this calculation, 4 millimeter distraction of this rod to get 1 millimeter or 0.25 millimeter every 6 hourly. So pre-operative planning, what you do, Frontal plane deformities in lower limbs are common and may lead to the degeneration in the hip and knee and ankle. When a translation component associated, the true apex of the deformity will be proximal or distal to the apparent apex of the deformity. See, it is very simple that when there is a angulation here, you have a deformity at this level, that is CORA. But sometimes the CORA may come at this level, at the joint level, where you cannot do osteotomy. You have to do osteotomy below the tibial tubercle or just above the tibial tubercle. That is at different level than the CORA. And therefore, a translation will occur if the hinge is placed at different level. Hence, while correcting such deformity, hinge must be put at the point of CORA instead of apparent apex. What apparent apex, you feel that it is here where you are doing osteotomy, but you have to put your hinge at the CORA so that the correct translation will occur and malalignment test becomes normal. What is malalignment test? Why to correct the deformity? To prevent early degeneration of the joint. Malalignment may arise from femoral deformity, tibial deformity, knee joint laxity, intra-articular condylar deficiency of the knee joint, or combination of the above. Malalignment in the frontal plane leads to mechanical axis deviation and joint orientation. In the bone, there is diaphyseal, metaphyseal, and epiphyseal. Now, to correct the deformity, metaphyseal deformity or epiphyseal deformity, you call as a juxtraarticular deformity. So, for practical purposes, there are only two deformities in the bone, diaphyseal deformity or juxtraarticular deformity. So, what is malalignment test? Take a full X-ray, join the center of the head of the femur to the center of the ankle, and that line must fall in the center of the knee. So this is the perfect, and you measure this angle, measure this angle, measure this angle, and that is 90, here 87 plus minus 3, here 87 plus minus 3 and 90 degrees here. So that is the perfect malalignment test. Now in this particular case, if you see, join the center of the head to the center of the knee and join the center of the head to the center of the ankle, this line. So that line is not in the center of the knee, and therefore there must be some deformity somewhere. So how to find out where is the deformity, whether it is in the femur or it is in the tibia or it is in the knee joint itself. Then draw the two condylar lines, femoral condylar line and tibial condylar line. They are parallel to each other. That means there is no deformity in the knee, and this angle is 87, so there is no deformity in the tibia. But if this angle is 95, that is away from the 87, that means there is a valgus deformity of this femur, though apparently it doesn't look that there is a valgus deformity. But if you do calculations, you will get 100% that where is the deformity. So, again the malalignment is center of the head to the center of the ankle, away from the center of the knee, that means there is a deformity. Join these two lines, join the center of the head to the center of the knee, and join the center of the knee to the axis of the center of the ankle, and find out what angle it is. It is 87 and here it is 95. That means this femur shows a valgus deformity. Another example, another line. This is a again malalignment test. The line is going away from the center. So you measure the two condyles, they are parallel to each other. May draw a line from the center of the head to the center of the knee, measure this angle, which is 87, then you draw a line from this tip center of the knee to the center of the ankle and measure this line, which is less than 87. That means there is a deformity in the tibia, Varus deformity in the tibia. Another example where malalignment test is done, the condylar lines are measured and you see that they are not parallel to each other, but if you see this tibia is 87, this femur line is 87 degrees angle, that means there is a deformity because of the ligament laxity of the knee joint by 5 degrees. So by this method you can make out where is the exact deformity. Another case, center of the head of the femur joined with the center of the ankle, it is lying quite away from the center of the knee and therefore there is a deformity somewhere. So you do the calculations, same way, measure this 87 degrees angle, measure this axis, allow this axis to go little ahead and draw a 90 degrees angle, and that makes a CORA. CORA is here, which is this between this axis and this axis, the angle is 26 degrees. So that shows that there is a valgus deformity of the tibia at this CORA level by 26 degrees. That is the, you know exactly. So when you do distraction or correction, you have to do it for 26 days to get this deformity corrected. So you put a block of these 2 rings here, block of 2 rings here. This is the CORA, this is your hinge, this is the distraction rod. Measure this and measure this distance between hinge to the concave border of the bone and divide that so that you know how much distraction of this rod to be done to get 1 millimeter opening here, and that you have to do it for 26 days to get 26 degrees, and 1 millimeter is 1 degree. So to get this 26 degrees angulation correction, you have to do it for 26 degrees, so it's 26 days. Another deformity where it is a normal femur and it is a tibial juxtraarticular deformity. So it is very difficult to find out where is the deformity, whether it is here by X-ray, by your eyes, whether it is here or here or here. So by calculations, the same type of calculation, which is 87 degrees outer angle of the femur, that means the femur is correct. The extension of this line, axis of the femur, and a line is drawn here and 90 degrees is done, which the CORA comes at the level of the joint here, and this angle between 2 axes is 37 degrees. So you have to do a osteotomy here to correct 37 days this deformity, but you cannot do osteotomy here at the joint level, and therefore you can do osteotomy below the condyle of the femur, of the tibia at this level, but you have to put your hinge at the CORA level so that you see here the hinge is put at the CORA level, and therefore you got little translation of this whole tibia, and you got the correct wall alignment test. If you don't do that, if you put a CORA where you are done the osteotomy, then you will get a alignment, you will get a straight alignment. By your eyes you will feel that the femur and tibia, they are all aligned. But if you see here, this will be like that and this will be like that. This will be little angulation here. So if you put a hinge here, you will get correction, and you will not get proper correction, but if you put your hinge at the joint level and osteotomy below tibial tubercle, which is possible, then you get a translation of the whole tibia like this, and you get a proper malalignment test. So this is a case, malunited fracture of the femur with shortening. This is the 2 rings here, 2 rings below, and this is the osteotomy of the malignant. And distraction started on 31 days. The alignment of the femur has come. So this is the 2 hinges and 1 distraction rod on the back side. So when you get a correction of your malalignment, your axis becomes equal, then you have to remove your hinges because they are weak. They cannot take weight, and therefore you put, instead of hinges, you take out and put your threaded rods, and take out that distraction rod from the back side and put threaded rods here. So you have 4 threaded rods so that the patient can take at least partial weight, because if it is a strong, heavy person, you cannot take full weight on these threaded rod also. And therefore you can at least he can take partial weight, but with the hinges he cannot take weight because the hinges will give weight. So this is very important when you do the lengthening or the correction of the deformity. You remove the hinges, put threaded rods, and let him take partial weight. So you can see that the alignment is complete, and you can take weight after the removal of here. Once the alignment is done, if it is a shortening, you can do lengthening also by doing distraction of these nuts between these 2 rings, and get a proper alignment and lengthening of the limb. Another case here, this is a rail side injury. This is a normal ankle, and you can see here the angulation of the talus. Because of rail side injury, his epiphysis is damaged, and which did not grow. This epiphysis, this side, grow, and he developed this deformity. Same principle, 2 rings, osteotomy, hinge, and correction. And you can see here the alignment has come absolutely perfect. The limb has become normal, and the length is correct. Another case, malunited lower 1/3 tibia. Ilizarov ring fixator, and you can see the correction and alignment of the tibia perfect. You can see the difference between previous one and after the alignment is corrected. You can see here clinically the lower 1/3 tibia fracture, malunited, which is corrected, and absolutely normal limb. This is a septic arthritis of the knee joint with a fixed flexion deformity of 115 degrees. You can see here, this is the femur alignment, this is the tibial alignment, and the angulation is 115 degrees. So a block of 2 rings fixed on the tibia, block of 2 rings on the femur, and the hinge has been put at the knee joint level, and gradually a distraction rod has been put here, which is distracted, and gradually the knee was straightened out, and you can see here the knee is completely straight. And this is the knee is straight absolutely. Another case of bilateral CDH, and bilateral, she had dislocation of the knee joints also, bilateral. So I tried to correct the dislocated knee. You can see here dislocated knee, posterior dislocation, congenital. and I put a ring here, 2 rings here, and then distracted this, distracted. Once that distraction has been achieved, see this distraction, then I translated this tibia under the femur. This is the distracted tibia has been put under the femur, and then I changed these hinges here and started movements at the knee joint with the Ilizarov fixator this way, and she could do extension with the distraction rod here, and this was the correction after the fixator, and she could bend and stand properly. But there is possibility of redislocation, that's why I have given her a brace for 1 year to use it. Sometimes in children you get a in osteogenesis imperfecta or like diseases, you get deformities, multiple deformities, where you can do sheikh kebab, do multiple osteotomies and put a rod and make this limb straight. So this is another method. This is another case, multiple deformities, osteotomies and rodding of these femur. So to correct the deformities in children where there is severe osteoporosis, where you can do multiple osteotomies very easily. So this is, you have to correct and give the brace for a longer time so that they don't fracture again. So if you do proper correction of deformity, you can do balancing like that and balancing like this. Thank you very much.
Thank you very much, Dr. Jhunjhunwala. Now again, young delegates who are hearing about deformity the first time would not have understood more than 10 to 20% of what you have heard. Don't worry. This is not Greek or French or Latin. It's a new language in itself, CORA and angles and planes. First time you hear it, you'll fall asleep. Second time you hear it, you'll fall asleep. Third time, some word will start making some meaning. Keep attending the conferences, keep reading. Eventually, you'll get to some extent. Till that time, stick to simpler things like fractures, non-unions and gaps and shortenings, and do simple deformities, not complex multi-planar deformities. So as we're running short of time, one talk by Dr. Jhunjhunwala has been cancelled, which is more or less a repetition of what we have already heard. And after this, we are having 2 more talks on Ilizarov and 2 more out of Ilizarov, after which we'll have our